meetup. We'll be talking about recursive functions and memorizations. We'll cover the meaning, the definition of recursion. And we know we have many recursive functions. For example, Fibonacci. So that's the one we'll be covering today. We'll cover what the Fibonacci sequence is and how to write the function in Python. Then after that, we'll cover memoization. And we'll see how to use it to make the recursive function more efficient. So what is recursion? Anyone? Mojo?
My hand first.
So everyone can give their version of the answer.
Yes.
Yeah. Calvin. Calvin can copy.
It's like repeating in a way. Recursion is like repeating.
Okay. Linda?
Recursion is going over, is recursive, back, yeah. Go up, go down, go up until condition is met.
Okay. Anyone? Penny?
Kujirudia or looping.
Okay, looping. Major?
Iterating through.
We can't hear you.
Iterating through.
We can't hear you.
Iterating through.
Sorry, I was out in my computer.
Okay, Getty?
Me, I have a saying. To iterate is human, to recurse is divine.
Now, does that give us the meaning of recursion?
No, but it's catchy.
Okay, who else had another answer? Okot or Kanji?
Recursion is
Unmute.
Recursion is repeating in a cycle.
Okay. So we are all right. Plus Getty's saying. So recursive is a verb which originates from the Latin word. I don't know how to pronounce that quite well. So I'll just say requere, which means to run back or to return to itself. Okay. Sorry about that. So recursive originates from the Latin word requere, which means to run back or to return to itself. So everyone was right about the meaning of recursion. So one of the definition of recursion is it's the process of defining a problem or the solution of a problem in terms of a simpler version of itself. So what they mean is they solve the problem in bits. So if it's a big problem, they'll start solving the problem in small bits, then the solution to the previous problem will help in solving the next problem. Yeah. So examples of recursive function include factorial and Fibonacci. I think those are very popular. We all know how to define them. Jackie, you don't know how to define. Okay, the Fibonacci sequence. Who can explain without looking at the slide? Linda, you had your hands up first.
So for Fibonacci, I think is a sequence where you add the first, second, it gives you Getty seems to object.
Just finish.
So you add the first and the second, and it gives you the next number.
Okay.
I think so.
Okay, you're not wrong. Getty?
She's correct, but her English is bad. So, Fibonacci sequence, it's a sequence of numbers, right? Different numbers. So the first number and the second number are added, and that becomes the input of the next addition. So if I have 1, 2, 3, if I have 1, usually 1 or
Yeah.
so if I have 1 plus 1, I'll get 2, right?
Yeah.
So the next time I'm going to add 1 plus 2, I get 3. The next time I'm going to add 2 plus, I think that's how it goes.
Mm-hmm, of course.
She's correct, but her English is bad.
Recursion.
So recursion, from my, the Fibonacci, from my understanding, is that adding, okay, the third, the sum, okay, the numbers which are consecutive, the sum of the consecutive numbers gives you the third number, any consecutive number, as long as there's any consecutive numbers. The sum of two consecutive numbers.
Yeah.
I disagree. 43, 44, 45 are consecutive. They're not Fibonacci.
Sum of consecutive numbers.
A consecutive number is a number that comes after the other.
Yeah. Two consecutive
1, 2, and 3 are consecutive.
So
Maybe say adjacent number.
consecutive. Example is when I say executive in this manner, I mean the pattern. Because you're following a pattern, you already know what Fibonacci is, right? So which sum of
We're
numbers?
defining Fibonacci now.
But I said your English is wrong. You say something which is correct. I said you're correct, but
You didn't say that.
meantime, I just repeated to the yeah. I think you're correct, but
Okay. I think we only need to improve on our English. The Fibonacci sequence is a series of numbers that are a result of adding the two previous numbers, as shown. So most people argue that it starts from 1, but even if we start it from 0, the logic remains. Yeah. Also, it is said that that's how rabbits multiply. Yeah.
logically speaking, it starts from 0 because 0 is the where I start counting.
Yeah, but even if you started from 1, it would still be correct. So
It's live, so.
okay, yeah, it's live, so that yeah, let me just see. You can see my terminal.
I'll just highlight it.
That's not a terminology.
That's my slide.
I'm not into your screen, but
Okay, so this is how we define the function, the Fibonacci function. If I'm wrong, you can correct me.
You're using Python?
Yeah, Python. It's a Python meter.
Inakuwa na date here.
Yeah.
Sorry? English.
Tell me of a language that doesn't have the JavaScript.
Keyword.
Kiswahili.
You can't say Kiswahili pia inakuwa na kumbe. Kumbe inakuwa na kumbe.
Yeah. Oh, so we are defining the function, or should I just use the ones that I already did?
Okay, we understand as long as you explain it to us.
Okay. So, in Python, we define a function using this syntax, def, then the name of the function, and whatever it takes. So here we have def Fibonacci. Let me just take what I need. Then I'll copy this. Okay.
The function Fibonacci takes in I.
Yeah, it takes in I. Then we know that if it's the first term or the second term, assuming that you're starting from 1 as the first term. So we have 1, 1. So the first one is the first term, the second one is the second term.
By time you need arguments.
The first term of the Fibonacci sequence, they start from, let me show you. So in the numbers below, this is the first term. Then this is the second term, third term, and so on. So if I, which is the input, is 1, then the Fibonacci is 1. So it turns 1.
You don't have semicolons in Python.
No. Also, if 1 equals 2, which is the second term, so if I is 2, it will return
1, 3.
Why 3?
Inachukua the sum of previous numbers. If previous number itakuwa 1
Mm-hmm.
and 2. The 3. Does it have memory?
At this point, no, we haven't reached there. So are we starting from 0? Since if we say the first term, 1 is the addition of the previous 2 numbers.
Yeah, we
So
start
it's
from
0. So we are starting from 0 in this case. Okay. So in this, if you start from 0, the second term will also be 1.
Where is it?
Yeah, it's the term. Yeah.
I, is it the position or is it the number?
It is the number.
First number. 1.
So, for example,
Mm-hmm.
0, 1, 1, 2, right? So it's I, in this case, 0 or 1.
And 1.
Where is it? Okay.
I is
I just want to know so that we flow. This is a level and it's a flow. So this is 1, 1.
You can copy those numbers from
Right?
your
So this is 1,
square,
2.
uh-huh.
then put them there as a comment,
So-
so you don't have to cheat.
Is this I, this one?
See, are you seeing my example? Don't just copy.
Okay. We change then if this is what you need. So is this I 2 or 3? The I we're talking about.
What? The second one.
So I is 1, this one.
So in this case, okay, I'm taking this example. It's I is 2, not 1. I is 3, not 2. In case you the right hand side. No, no.
Yeah. The one that has 1, 2, 3.
Okay.
Yeah. So it's I.
What did she say? I is?
It is the term.
So is I the term where the term is 3 and I is 2.
Let me explain according to how I understand it. From the definition of a Fibonacci, it's the sum of. You can refer to your story.
The sum of the previous two numbers.
Two previous numbers.
Yeah.
So we have this one and this one. These ones are two previous numbers before these two.
Yeah.
So sum of this 1 and 1 is sum of this 2 and 3 is 5. So sum of this 3 and 5 is 8. So that's the flow. So in a case where when I is 1,
Apart from assume Fibonacci is not 1. Okay, after assuming that, count these ones. 0, 1, 2, 3, 4, 5. How many are they?
Okay.
So,
People.
yeah, you realize what we said. So it's equals theta, right? It's equals theta. So is I 6 or 8?
Unauliza gani iko 6?
Is I the term or the value?
The term.
It's the term. See, if I is 1, the return value is 1.
So if position is 1, the return value is 1. If position is 6, the return value is 8. When they make sense?
By position unamaanisha ati like this at position 0.
I have a question.
If it's
I have a question.
yeah.
So here we say I equals 1 and 1.
Yeah.
But is there a place where to make a like I like there's no like a phone somewhere where for I is
No, see, I in this case will be interesting.
or you don't think
Yeah.
So,
I
okay,
is
they may like to understand what it is.
You get it?
Yeah.
Okay, so if it's the second term, it will also return 1. Yeah. So if I is greater than 2, that's when I will calculate the Fibonacci. Of I. Well,
to make a column.
Yeah, following the-
this is Python. This is how we do things. Yeah. So it is the sum of the two previous numbers. So the two previous numbers before I is I minus 1 and I minus 2. Oh, me too. I minus 2. Yeah. So we can now call it. We don't have end.
We don't have
Python.
semicolons, we don't have ends.
You
Is indenting still a problem for Python?
Indenting, yeah.
Interpret.
It is just the way we do things. We like it like that.
Python standards.
Yeah.
It's called it. Whatever topic it
Integrated.
Whatever starts with W.
is.
So in Python, if you what do you call it? If you write a range like 1 to 51, it excludes the 51. So it's 1 to 50. So this is how you write it. Yeah.
You can use 3 dots to include it.
Pardon?
Sorry.
Yeah.
Nimetaja.
So I think we can now run it to see how it works.
Oh, Python 2.
Oh, sorry.
It's Python 3.
Yeah. Yeah. Oh, we have an error.
I knew you had a
Invalid syntax. For I in range.
Well,
Oh, it's not colons, it's a comma. Sorry about that.
wait. Range nimesema na comma.
Yeah, I got confused because of Elixir. Yeah. Ooh, more errors.
Unsupported operand type S or types for class, null type and int.
line 12.
Adding
Line 12. File mom. Not file line 12.
Line 12 and line 9.
Patience.
this is my boy.
Bonnet. Okay, who can spot the error?
About present.
No, I see the error.
Okay, tell us what the error is.
Data.
That's not helpful at all. But we've expressed it here as
For I in that range.
But you may call it to do. How can it know that I is that way?
You call it down there.
Like upper, right? Python is interpreted. It is interpreted.
yeah.
So I do I mean at that given moment. Upper team may do I do, but at this given moment it doesn't. I know it sees I as a at line 9. Sees I as a I don't know it works. I really ain't doing it.
What do you do when you define one function? You give it only when you're calling it is when you do something. So 9
So
is still part of
which
the
argument are we giving?
but 9 isn't it part of the function?
Question is,
Yeah.
is it still part of the function?
No. The last
Sindio.
But either way, what is I?
I is each number in this range 1 to 50.
it will be looking through. First time I will be 1.
Linda. Okay.
Can we have a look at the error again?
Yes. Type error.
The operand.
Unsupported operand for that.
Oh, for class and of column.
Omega plus and colon.
Make a space in between.
Oh, ujeka colon hapa basi.
Na hapa ifiko na column.
Nasema hii space after Fibonacci 1 minus I minus 1.
Here.
Python iko pretty.
You think that's the issue? Still the same.
It should go for the 4. It's not looping through, so it's never getting I. That's why it's saying.
Yeah.
That's why it's saying I is a null type. And
Okay.
it's adding it to an integer.
Okay. Jackie.
I think the problem is upper I minus 1 is an integer. Variable.
I minus 1.
Yeah.
So I is the
User input.
I is the input.
Yes.
So we're checking to see if this I that the user has inputted is 1. If it's 1, it will return 1 as the Fibonacci. If it's 2, it will also return 1. But if it's greater than 2, then it will do this calculation.
Here is at my mind. I have another idea.
Mm-hmm.
The 4. Can we try it in your IEX?
Yeah.
Maybe you just try removing that comma. Then you put 51, let's see if it works. If it doesn't, then we work from there.
Okay.
51. Oh, you put 1. Oh, enter. Series
So umesema nika 51. Range haiwezi kuwa one number.
Hiyo 4 inatoa hiyo. Iweke 1 2. Hiyo itakuwa one number. Like up to. I am counting up to 51. What is that?
Oh, range.
Up to. Nikisema up to, what is that? Nimesema from where? Nimesema up to 10. What is that?
So you can try hivi venye meka. Just put in now.
Okay.
You see if it works. So that's the simplest case.
What should I? 3. Okay. Okay. Now who knows what's happening there?
Mbona sijaona kitu kwa terminal?
Sindio, it's not doing anything. Who knows why?
Because it worked.
You have to print it or you have to return it. Yeah.
I have a question.
We do.
They have a PRB. Yeah. No. I have IPY.
None.
Why?
Why none?
Maybe return
Weka return kwa Fibonacci.
Return Fibonacci.
Yes. Like that.
Okay.
In Python, you have to explicitly return.
Yeah. So now we can try our range again.
In PYX.
Huh?
In PYX. In Python. In IX, yeah.
No, in our code.
In their IRB. See, it refused to work, that's why.
See, we don't abandon things that refuse to work.
See, we tried it in IX.
Okay, let me just say it here first.
We write them in code, then try them in Py. Hey, just a minute.
50.
Yeah.
Will it work like this?
No, just like the smallest.
Then we let the
Print.
Oh, Python juggled me because of the expression.
You're sure that's how? Oh, yeah.
Oh, you don't put a range of 1 to 4. CLE 50.
Mm.
Nimetoka code. Hatujui kuna 6 participants. Kwa hiyo wanataka. Ya machine vizuri. Nimejitoa.
Can see how slow it is.
Yeah. Which hatufai kuweka 1 to something.
Tunaweza,
Or tunaweza weka.
but yeah, this is another way of kuandika your range.
Okay.
So it will just continue like this slowly. So this is where memorization comes in. Yeah. It's like, let me just stop it there. Yeah.
Hebu nione the previous one ulikuwa nayo.
Then,
Yenye ulikuwa already unayo.
hii ni yenye nisha implement memorization. Sorry, I'm plugging in my charger.
Remind me after this to ask the basic question.
Okay. So we've seen how to define, because we say 50, it's like counting from 1 to 50, every number before 50 to 50. So this is the function that we just wrote. The Fibonacci function, it works well if you're finding the Fibonacci of the first few terms, but if you want, let's say, to find the Fibonacci of 1,000 terms or 1,000,000, it will get slower and slower every time. So this is where memorization comes in. Not that we've seen that, who knows, who can try to define memorization? Try. Okay, get you. Yeah.
I think it's just memorization, but they remove the R. So it's like keeping something in memory or something.
Okay. Mojo.
Okay, because for the first few numbers, we have them being output faster. Then as time goes by, it slows down.
Yeah.
So memorization helps us in increasing the speed
Yeah.
to balance the rate.
Okay. First, try. Yeah. I'm putting a separate memory. You can't speak loud.
I think maybe is allocating some memory for it to run when it's on, as well as maybe a memory is allocated to that. Something like that.
Okay. Calvin.
Memorization is like storing something so that you can use it at a later time, so that you can, I mean, pass the next time you run the function.
Okay. Anyone else? Okay. So you're all right. Memorization, it works by, it stores the result of the already computed problems to use them later. Yeah. So that's the technique we are going to use. So yeah, it's like caching the result of the already computed results so that you use them later. Yeah. So this can be done in two ways. You can implement it explicitly, or you can use a built-in tool. Uh, because of time, I'll just go through the code that I wrote. So who can take us for the first line? The first line. Who can tell us what's going on the first line? Get it? I saw your hand half up.
We are declaring an empty data type. I don't know what that data type is.
It's called the dictionary.
We're declaring a dictionary. Yes.
Yeah.
A dictionary.
Dictionary.
Oh, I have a question.
Yeah.
Dictionary is like a map in Python, like a hash.
Yeah. Hash in Ruby, map in Elixir.
Yeah.
Yeah.
But the percentage.
Oh,
The third line. Tell us. We don't know what you're saying. We don't know what you're saying.
It's a function definition. That's what I think.
just add.
Okay. Line 5. Angie.
Auntie, we can't hear you. Auntie, whatever.
Line 5. Uh, in used to start the if function, a condition, the if condition. It's just to start the if condition. You start with if, then go to the last else if or the last else.
Okay. Anyone else? Linda?
Can you?
Yeah.
Am I not clear? Line 5 is used to iterate through the contents in my storage.
Yeah. Of course, you had something to say.
Yes. Check if the word was cached and it returned it. And returned it.
Okay. Don't copy paste here. Yeah. So when we are defining the Fibonacci function and we're using memorization, we can do it explicitly by having a dictionary where all the recursion results will be stored. Then later on, before we start calculating our Fibonacci, we first check if there's a result matching that term that the user has entered. Yeah. So from line 8 to 12, it's just a repetition. Calvin, take us through line 8 to 13. We can't. Yeah.
You check if I is 1. If I is 1, the result, it gives you a result of 1. Then you loop, you check if I is 2. If it's 2, it still gives you 1. Then if I becomes greater than 2, the result will be Fibonacci. You will take the I that is greater than 2, you subtract 1, and then you add to the I that is greater than 2, you subtract 2, then you add 2.
Okay. So, line 15. Mojo, what do you think is going on?
So in the 15, it takes the by storage and it's in a list of elements. So it equates it to the result, and so it returns the result.
No.
It has
Okay, this one. Can I take this?
Yeah.
Oh. Okay, if you look at that thing, look at it clearly.
right?
15.
15. That was it is like it's literally inserting the results into that list. That was I'm saying. Yes.
I think it's really, it's what? Pardon?
So, and then it returns the results.
See, there is and if I is my storage return the storage.
Yeah.
So
We can't hear.
this returned by storage is what is used down here, and we give it the result. such that it will return finally the result.
Anyone else? Betty?
I can try.
Yeah.
So my storage was the empty dictionary.
Yeah.
So dictionary has key and value,
Yeah.
and from there I'm lost because results. Yeah, it's empty, and then results is supposed to return a number like 2 or 5, isn't it? So I'm thinking it returns 5, and then we are accessing my storage. This looks like we are accessing my storage. My storage is a dictionary, and then we're accessing the I index, and we're storing results there. So I don't know how it would have a key and a value, but that was the information.
Linda?
For me, I think the I in that my storage is one. Is just one number. So, because in line 5 we are saying for I in my storage, so it means it picks one number at a time, one number at a time. So by the time it's reaching here at 15, it's storing that I, your number moja, let's say if it's 5. So I hapa itakuwa 5, and the 5 is what is being put as a result. Alafu, we are returning that 5.
Okay.
When
Sorry.
Let's. Yeah, I have a question.
when you accept in the dictionary, there's a key and a value, right?
Yeah.
So when you access the key, you get the value. Yeah. So what we are saying that you are lost from there. Somebody else.
Yeah.
It's very wrong, but I'll just say it. So, for my storage, the way Linda has said, I'm thinking anytime it's looking through the Fibonacci, it's storing all those numbers as keys. So the first time it will store 1. For example, if you're finding Fibonacci of 3, the first time it will store 1 as a key, second time 2 as a key, third time 3 as a key. And then when it comes down here, for the line 15, it puts the result of 1 as 1, puts the result of 2 as 3, or it puts the number and its Fibonacci. The number and its Fibonacci. I'm thinking something like that.
Yeah. Because the way if you enter a number like, let's say 6, it will calculate, it will do Fibonacci of 5 plus Fibonacci of 4. And Fibonacci of 5 also has to be broken down like that. So that's why they store the result in my storage. So if in a later, sorry, if in a later problem you come across maybe Fibonacci of 5, you already have that in the storage, so you don't have to calculate it again. Yeah. So after you calculate it, the result that is calculated is also stored in my storage, so that it can be used later. So it stores it first, then it returns the result. Yeah.
So every time. Can I hurry this?
So the function of this, I'm asking myself how this is helping us.
Okay. You see now the same thing in life, right?
No. How it's going to help us in the long run if we are finding Fibonacci for, let's say, the input is 6. See, the result will be the same.
How will memorize?
Let me ask you something. If you are putting, what if you're looking for Fibonacci of one?
Order.
If you're looking, if you're looking for Fibonacci of 1 million, how about that?
The system will have.
But straight with memorization.
15 and 21. So if it's much, it will take shorter.
Oh, yeah. Get it?
Sorry. I remembered something we were being taught in Nonga. No, I wasn't a student. In Elixir, where, what was this? The head and the tail, where something was being stored in memory, and anytime we wanted the same thing, we would just get a reference to that. We'd get a reference. It was Elixir, head and tail.
Something is still memory.
It was recursion, I think.
The accumulator.
The accumulator. So something gets stored there, in that when I want to use 1, 2, 3, and 1, 2, 3 is already on my memory, all I do is reference it. I don't have to do 1, 2, 3 again.
Yeah, so this is just like an accumulator.
Yes. Yeah. So that's memorization.
Asking the importance of this, like on a physical level, that computer cannot handle it anymore. So in such a case, that's called stack overflow, right? If the stack is full to the brim. So for avoidance of the same, what the reason what wanakupanga recursive function, especially for OO, not for functional. In fact for functional wana encourage kutumia recursive. But in OO, people tend to get, like, they fear the recursive function because of that stack overflow. So in this case, you realize that when you use memorization, it helps you to avoid some cases of sort. So that's a very helpful memory, whatever.
Memorization.
No, memory.
Lapse.
Memory. Save. Yeah, so that's a very important aspect. So I think it helps us so much in something of sort.
Welcome, Daniel.
Karibu.
Okay, so now we'll just test to see how it
Asante.
Yeah. Yeah. So that's how you can speed up your recursive function.
I have a question.
Yeah.
No, a suggestion. Can you do the same on 5
What
as a range?
we have tumefanya from 1 to 101.
Sasa fanya ya 1 to 5. Tuone how fast. How fast. Milliseconds.
Get it?
I have a suggestion.
Yeah.
So now we can play around.
Yeah.
Now, instead of printing out of returning results, can we return my storage to see how it looks?
Okay.
No.
No, that one doesn't help.
If you return it won't mean you have to print it.
And then
Oh yeah. It's indented.
I thought
I
it
don't
was
think so.
asking instead of returning results, we return my storage.
Return my storage.
Yes.
You know, returns, it just returns. It doesn't.
Yeah, it will return my storage,
Okay.
but we want to print the Fibonacci down.
I return my storage, then I print it.
So you just I'm just return it.
Yeah, that's what you have. So the Fibonacci of 1 is 1. Yeah.
Beg to disagree.
The thumb.
Fibonacci is a series. It cannot be a single number. Thank you very much.
Lead us through the second process. How do we do that?
So yeah, like you know, dictionary has a key and a value, right?
Yeah.
So in this case, this is what I was asking from the word go. In this case, you see key 1 it has the value of 1. So where if you know when I'm in position 1, if you know, but Fibonacci value of that is 1. When I'm in position 2, Fibonacci of 2 is 2. Try it out. When you're in position 6, you'll find the Fibonacci of
8.
Position 6. The number, the value at that given moment is 8. It is a series. So the key is the position at that given moment.
And the value is
You'll come to realize that as you go. Okay. As we go, then like the numbers. Like for example, we don't have okay for position. Let me say which position. Okay, position 5. Yeah, position 5. The Fibonacci will be 5, right?
Yeah.
It goes along like that. So where the first term is the key in this, I know the okay the non-EU dictionary kuna elements. The first element and 1 2 1 1 that is key value key value key value key value. Where key the position and then 1 is the value. Is the position.
That's interesting.
Yeah. So the second method is easy. You just import what is it called? Yeah. You import functools, which is a module. Yeah. Yeah, Jackie.
So in the second method, you just import the cache. You don't define kwa function yako, kwa nini yako.
What?
In the second way of doing it, you
Yeah.
just import the cache.
Yeah.
So ndio store data hapo. Okay.
It's called a decorator.
Decorator,
Yes.
like decorations.
Yeah.
Oh. Thank you.
Yeah. So basically, that's it. I'm muted. Am I muted? So also something interesting about memorization, about Fibonacci. I mean, the Fibonacci of consecutive terms is the golden ratio. I think Okoth talked about it. It's 1.6 point something.
The ratio of the
1.6. 1.6 and other numbers follow.
It was Sigo.
No, it was
No, it was
it is 1.68. It is a very
One-
beautiful number. But
I
it
think-
only works as you near infinity.
Why not?
Because okay, for example, let me give an instance. 1 ratio 1 is 1, right? But okay, Collect, you can try this for us. I want to see the Fibonacci of maybe let's see 700 there. You'll find that its value nears 1.68.
So if you're
1.168 or
close to-
1.68. It's a very beautiful number.
Yes.
There's an app for that. I want to try it. I hope so. I think that's what
Oh.
just Sergeant did.
Hello, Dan.
Yeah, so that's all for today. If you have any questions, you can contact me. You can DM me on Twitter. My name is P Obuya. P_Obuya. Yeah. So keep it locked.
Thank you. That was awesome.
Yeah. The end. Yeah, done. Say something.
We're giving up on.
Hello, guys. Hello.
Hey.
Can you
Hi.
guys hear me?
Yes, you can.
Yeah. So I'm Daniel Otieno from Mombasa.
Ooh, welcome.
Thank you. So Sigu is a very good friend of mine, but sasa itabidi tumekosana. You okay? Last year I participated in this session.